we're going to talk about the parent functions today, what their graph looks like and what transformations do. So we're going to identify those characteristics of those parent functions as well, again, as their transformations. All right, so a parent function is going to be that simplest form of a function that's going to define the shape of that function. So like the parabola or the quadratic has a specific shape to it that will always be the same, and then we can transform it based off of parts of the equation. The first one is a linear function, and it's going to form a straight line. Like it's going to be in the form of y equals mx plus b, or in the form of the standard form, which can be written as x plus y equals 1, okay, as well. Then we've got the quadratic, and its parent function is going to be a U shape. Okay, it is symmetrical. So besides its vertex, everything else is going to be symmetrical. If we folded it in half, it would land on itself. The cubic function, okay, is actually symmetrical about the origin, and it looks very similar to when we get to trig graphs. It looks like the tangent function. But again, you need to know the shape. It's kind of a sideways S there. We've got the absolute function, which is very similar to the quadratic function, except instead of a U, it's now a V. It comes down to a point. And again, it is symmetrical, just like the quadratic function. Then we've got the square root function. Okay, and it's just an arrow going upwards forever. We've got the cubed root function, which is a horizontal cubic function. So we've taken the vertical and now switched it to the side. The log function, again, is kind of similar to the square root function, but it goes on forever in both directions. It gets closer and closer to 0 forever, but never actually touches it because the log is undefined. 0 or for until we approach a negative number. And we've got the exponential function. It's like a roller coaster kind of going up there. And it approaches 0 forever there on the x-axis where the log was on the y. Here we're going to talk about the transformations of those graphs. So here are all of the transformations written out. All of them have an A, an H, and a K. Remember, the H and the K are going to represent something. The A represents something, which we're going to talk about in a second. And for the exponential there, you see the C there as well, which is its growth. So the A is going to stand for amplitude. Okay, it stands for amplitude. And then the H stands for horizontal movement. The K stands for vertical. A lot of the time it's where we get our center point or our vertex from. Okay, for things such as the circle or parabolas and things like that we're going to talk about in conics. But here again, horizontal movement is H, vertical movement is K. So here is our function. For A, we would have a value of 2. Okay, for H, positive 5, and for K, positive 4. Remember, it is the opposite of what you see there for the h value. So when we come over and we plot it, we're going to move 5 to the right and then 4 up for our vertex. Okay. Um, okay, in the normal quadratic function, we would go up 1 on either side, and then we would go up 2. But because the amplitude is 2, we're actually going to go to the right and left, and then up 2 to mark our points. So there would be our quadratic function there. All right, now we have an absolute. Um, we've got a 1/2 for our a. It's always positive, but the negative is going to cause us to flip the graph. It will let me write it. My board's being a little touchy. All right, so it's flipped. And then our h is going to be negative 2 and our k 1. So we're going to go negative 2, up 1, plot a point. Okay, and then we're actually going down a slope of 1 and over 2. So we go down 1 and over 2 in either direction. And we'll have our graph, if my graph were staying where it's supposed to. All right. So that is going to be it for our notes. If you have any questions, please see me in class. And again, I do apologize for the video and not being able to write very well on the board.